Okay, so copy and paste this. While I'm copying and pasting, if you don't have a flashcard that describes what is meant by a relative max, you need to create one right now. So if you don't have that flashcard, grab one. You already have the information, and it's something that you should have had memorized weeks ago. One other warning, if you are I told you this in class, if you are waiting to memorize until the night before the retake, you're done. Like, you won't do well, okay? You won't. Like, you have to memorize now. I showed the first session that what you should be doing is you create a flashcard deck, and then every single day from now until the retake, you go through that deck multiple times a day, but not all at once. Like, you just have a spare moment in the morning. You go like this. Check your flashcard. No, that one. This one, dang, I forgot. Yeah, I don't remember that either. You make two decks, okay? The known and the unknown. And then an hour later, you just pick up the unknown deck and go through it again until you don't have any other unknowns. Then don't do any more that day. Next day, do it again. Eventually, you get to the point where you don't have unknowns. That's where you need to be prior to the retake. If you try to do that the night before, I guarantee you won't do well. There's a lot of classes you can cram for. Calculus isn't one of them. So anyway. So you need to have a flashcard that says this. It's right here. You have the sheet. This is not new information. F has a relative max when F prime changes positive to negative, which means F is changing increase to decrease. So if I were making the flashcard, on one side I would just write F has R max. On the back side I put all the rest of the information. Questions? I do not make a card for relative min because it's simply the opposite. I feel like I can remember that. I don't make a card for relative extrema either, because a relative extrema is simply a relative min or a relative max. So one card does all I need for all three things. Questions? So Caleb, talk to me like what you were thinking on this problem so we can kind of deduce what went wrong.
So I thought it was going to be it changes from negative.
Possible ones. You're doing great, Caleb. 3 points. Mark them down. Mentioned in the first session that I'm going to give out points for this. You can use those points either for term 1 or term 2. If you've already turned in your term 1 points and you want to save up more for term 1, when you're ready to turn in the extra one, just send me an email. So, Caleb did something that is really common that we all must not do. Yeah, you got it. Yeah, you can't say it. So try again. Go ahead.
Okay, so F prime changes from negative to positive.
Pause for 1 second. One other habit that's also really helpful, Caleb, 3 more points. Get in the habit of saying F prime like you did, also X and Y. I promise it'll save mistakes. So F prime changes positive to negative at X equal negative 2.
Yeah.
Let's pause there. Anybody have a question about that? Keep going.
So F is going to have a relative at X equals
3 more for Caleb. It's perfect. Question? Somebody else want to jump in and do exactly what Caleb's doing? Just continue his thoughts. Sydney.
Well, I have a question.
Please.
Does it work if we just draw out F and then just like find the relative maximum points of deflection?
Sydney's asking if it works to take the graph of f prime, and from f prime draw f. It is a valid way to solve the problem. I don't recommend it. It tends to lead to mistakes. Like, I actually think it's a lot faster just to use the flashcard in Danica's chart, but it's not wrong. Is that your question?
Yeah.
3 points. Somebody want to pick up on Caleb's thinking and follow his thinking and start talking? The more you talk, the better you learn, so we'll just wait. Mia, please.
Okay, f prime of x changes positive to negative at x equals 4.
Hold on a second. So f prime changes positive to negative at x equal 4. Anyone have a question about that? Go.
So f prime has a relative minimum.
Careful, f.
Or yeah, f has a relative minimum at x equals 4.
Maximum.
Oh yeah.
3 points for Mia. We're done, that's it. Well, we got to do the inflection thing, so. You good to that? Okay, you need another flashcard. It's right here on your reference sheet. Right, come on. This one. It's right here. This one here. You need a flashcard that says on one side, F has inflection point. Flip it over, has all of that on the back. Go, make it. We'll wait. So usually we have time in class for what I hope are true stories that help motivate you. The one that sticks in my head is the one I've been telling for years. This student knows I tell people about her. Her name was Emily Bernard. It's like 10 years ago, 12, I don't know, it's been a long time. Emily took test 1, true story. She got 3 right. No kidding, no exaggeration. She got 3 right on test 1. She did what you're doing. She came to retake prep. She was very good. Going to compliment Sydney. 2 more for Sydney. She was very good at asking questions, like very good at listening, but also saying, "Wait a minute, I don't understand that," or "Can you clarify that," or whatever. Right? Just very persistent. On the retake, it didn't go perfectly. She missed 7. Okay. Huge improvement. I mean, she went from missing 22 to missing 7. So, big jump there. But the best part about it was, from the experience, she really did learn how to learn calculus. She got a 4 on the AP test. Okay? So, just, all you have to do is be persistent. Had a student my very second year teaching calculus. Her phrase was, you'll be successful at calculus if you are consistently persistent. Like, you have to be with me, you can't lose track of me, and then you just persist, okay? All right, back to here. Somebody else use that flashcard and tell me what I should write down based on that flashcard. Please.
F prime has a, or would it be said F has a point of inflection? And then we reference F prime.
You can actually do it either way. Either way. Yeah, either way. Max,
So
right? Mike, right? Mike, sorry. So go ahead, Mike.
So F prime has a inflection point.
Oh, be careful there, be careful there. That part can lead to errors because we're not looking for F prime has an inflection point.
So F has.
We're looking for F has an inflection point. But we're going to find that, Mike, by observing what?
Well, so at x equals -1.
Let's write that down.
F
Hold on a
prime.
second. Now you got it. Let's go. At x equal -1. Oh, you want to be really ready for these kinds of problems on the retake? Do exactly what I'm doing. Write out the words. Promise. You'll be way more prepared than if you just think them. Because it's exactly what Mike's doing. You stop and go, wait a minute, that's not right. Then you fix your wording. Sometimes when you say it in your head, you don't do that. So tell me again, Mike, what are right?
So f has an inflection point at x equals -1 because f of prime has changes from increasing to decreasing at x equals -1.
There we go. Perfect. 5 points for Mike. Question. Please, Jake.
So like this is kind of different, but like when I was doing this one, I got the points of inflection, but I didn't get the min and max. I still guessed the right one, but so how do I know whether it's a min or a max? Because like I know we did it, but like I don't think I understood it.
You're okay. So we just need to talk for a minute until it clicks. So Jake's question is, I still need a little help really understanding how I know whether f has a relative min or relative max.
Yes.
Correct? Okay. I'm repeating the questions because people keep reminding me that on the video it's hard to follow my discussion when I don't repeat the student questions. So read this one to me and tell me, Jake, if it makes sense or not. If it doesn't, that's fine. But just tell me when you read this, what happens.
So f prime changes negative to positive at x is -2. And so because of that, it has a relative min at x
Careful,
equals
careful.
f has a relative min at x equals -2.
Now pause for a second. Does that make any sense at all?
Well, it makes sense that it's there, but like I don't know why it's a relative min instead of a relative max.
Gotcha. Okay, look. Everybody, look at the board. Okay, I know a lot of you can do this with a shortcut method and be just fine. I promise, if you'll make sense of the next 3 minutes, you suddenly will, your understanding of this will improve dramatically, and it will never fool you again. Because Jake's asking exactly the right questions. Like I can see the connections, but it doesn't really make sense to me. So everybody answer this question and make sense of it. This is the graph of f prime. Don't say it out loud, raise your hand. This y-coordinate is negative. This y-coordinate is negative. This y-coordinate is negative, okay? The y-coordinates of f prime tell us what about f? Show me your hands. Come on, gotta know this. What do the y-coordinates of f prime tell us about f? I was gonna ask Reed, but he's taking a snack there, so it's fine. Just keep going on the applesauce there.
Well, I think I had it.
Oh, go ahead, please, please. Oh, you forgot it.
Yeah.
Alan. The slope. Hands up if you knew that. Come on. 2 points. 3 for Alan. The y-coordinates of f prime tell us the slopes of f. Raise your hand and tell me. If this value is negative, that means f's slope is negative. So at this x-coordinate right here, about x equal -3, is the graph of f going up? Is the graph of f going down? All we know is the graph of f has a negative slope. Hands up. Which way is f going? Louder.
Down.
Down. 3 points for Bronwyn. Okay. If f prime has a negative y-coordinate, who knew it? Come on, hands. 2 points. If f prime has a negative y-coordinate, that means f is going down. So, lots of extra points there. Raise your hand and tell me. Right there, x equal -3.5, sorry, x equal -2.5. Hands up. Is f going up or f going down? Hands up, come on. At x equal, all I have to do is read the graph of f prime. At x equal -2.5, is f going up or down? Sorry, Dave.
Down.
How many agree? 2 points. I've given away 3 points. Please read. Oh, Christ, it's all on the drop. You're good. You're good? So you know right here, f's going down. Right here, f's going down. Right here, f's going down. Okay? Right here. Hands up. What's the slope of f? Hands, come on. What's the slope of f? Jake?
0.
0. Here's what f did. So this is what Sydney's doing. Like she was solving it by drawing it. Nothing wrong with that. Just a little longer than I like. So F's going down. Right at x equal -2, F has a tangent slope of 0. Now right here, just say it out loud, F's going up. That's a relative min on F. Does that help at all?
Yes.
Okay. If it doesn't, you can always say no.
It makes sense.
Okay. Yeah, that's what this means. Danica's chart is not magic. It's just a summary of what really is not that hard to understand if you just think for a moment. Yeah. Please, you have a question.
Let's go back to the inflection points. I've talked to you about it like many times, but
You're good.
I seem to not get it. Because it changes when F prime is changing from.
So back up one step. Just say everything again without making me feel bad.
When F prime changes from increasing to decreasing, or does it go both ways? So increasing to increasing as well. So it changes it as F prime changes from increasing to decreasing. F has an inflection point. So I think I did it right. It's both at 5, like x equals 5.
Oh.
That's not changing, right? Is that what as I said it would be 4 points, but is that where I got wrong because I said x equals 5 was an inflection point?
Perfect. Let me ask it back to you. Say it so the video can hear it. So Caleb's asking, wait a minute, I thought x equal 5 would be an inflection point for F, but at x equal 5, F prime is not changing from decrease to increase. F prime is simply decreasing and then we don't know. So we can't make an assumption. So that's why you couldn't include that one.
So that means like it's not just F prime. Whenever F prime slope is 0, that doesn't mean that it's an inflection point. That just means the slope is 0. But if it switches, if F prime goes from decreasing or whatever, that's when it's an inflection point.
Yeah, the flashcard is strictly true. That is a common way they try to fool you. So no, the flashcard is strictly true. F prime must change, increase to decrease or decrease to increase in order for F to have an inflection point. If F prime simply has a value of 0, that doesn't guarantee an inflection point on F. There you go. Okay, you are guaranteed to have 7 problems on the retake that's going to probe you. That sounded terrible. That did not come out right. It's on the video. All the dumb things I say end up on the video. Anyway. Sorry. There are going to be 7 to 8 questions that make sure you understand this idea. So if there's anything about this, you're like, I'm not comfortable yet, do exactly what Jake did, 2 more for Jake, talk about it, okay? Anybody else? You have a different question. Just for a hand to be raised.